the downlink that you were able to see a few minutes ago. It was so cool to see the astronauts bounce around in space with their basketball. And it made me think about when they talked about whether there could be sports in space or not. I thought that yoga might be a good athletic event that they could try while they were in space. So I was hoping that while we're back eating again, that we could try to see what we remember from some of the yoga postures again. So if you want, I'm going to give you a minute or so to stand up, and then I'm going to go back to that part of my office that I was in before, and we're going to see what poses you might remember from the time we met this morning. I hope everybody had a chance to eat lunch and have some time maybe to work on their space activities that Taylor made. I'm going to drop it down a little bit further still. Okay, so I want to know if you guys remember star pose. So I said a star has 5 points, so we can try to make our body have those 5 points again. So here's 5-pointed star pose. One thing I always have to remember in this pose is I want my arms to be kind of even. That can be kind of hard here, but this is star pose. You guys can do that again with me. And then if you remember some of the constellations, you can bring your feet together. And then we brought our arms out in front of us this way to make Orion, which is the hunter. So you can lean 1 foot forward and then bend into the knee. Now our bodies are shaped like a hunter. I know we did it this way in our last meeting. Let's try to do it on the other side too, because I know last time we didn't do that. So you can turn to the opposite side and put your arms out in front of you again. Pull your arrow back again. And then this time maybe you put your other foot in front of you. You look over just like you're ready to hit a target. So we're acting like the constellation Orion as a hunter. From here, you can kind of just come back into that 5-pointed star if you want again. Bring your elbows up, so bend your elbows, bend your knees, and now we look like the queen, Cassiopeia, up in the sky. Maybe later today you guys can ask your friends or your parents if you can stay up a little late and look at the stars when they come out. So this is Cassiopeia, and then I don't know if you remember the last one, but it looked like a bear. So if you remember that one, you can go and start to put your body in the way that looks like a bear. And then I'll join you. So bring my knees together again. I bend my knees and then I reach forward like a bear, like this from the side. We said that was Ursa Major. It's part of the Big Dipper. Now we're going to come back down to seated if we can. And we're just going to keep a nice easy posture this time. We won't have to put our feet in front of us. But what we're going to do here is that we're going to see if, again, we can remember how the earth revolves around the sun. So remember your sun right here where your heart is, where all the light comes from. And then you're just going to make some rotations or circles in one direction. Just imagining that you're the earth revolving around the sun. And then we're going to go in the opposite direction. So again, you can make those circles. And then the last thing I'm going to have us practice again was that really hard one, the one that astronauts probably have to work on all the time when they're wearing their space helmets. We're going to try to do those eye exercises. So try to keep your chin still. And then we're going to look up towards the sky. Maybe you see some of those constellations we just talked about up there. And then you can look down. Looking down, maybe you see your moon boots or something that reminds you of the surface of the moon. And then we'll look over to the left side, or the right side, sorry. And then the left side. And then for the last one, you can hold your thumb out in front of you. So my arm is straight, it's not really bent. But what I want you to do is imagine that your eyes are the earth and the sun is your thumb. And you're gonna orbit your eyes around the sun. So you're gonna move your eyes in a big circle around your thumb. trying not to move your head. And then you're going to move your eyes in the other direction. It's challenging, I know. And that's how we're going to end the yoga part for today. But now we're going to turn our attention to Miss Taylor, because I know we started to talk about some of the things you might see when you're in the night sky. She's going to tell us more about what actually makes night. So why would there's a difference between day and night. So go ahead, Miss Taylor. Nice to see you again.
Nice to see everyone. I hope you had a good break and a nice lunch and great yoga. All right, so as I'm sure you remember from our first workshop, how I'm going to start off is I'm going to ask you a question, and I want you to think in your head about an answer, and then I'm going to give you a couple seconds, and then I'm going to tell you the answer to it, okay? So, have you ever wondered when we go to bed at nighttime why it's dark out and not light outside like daytime? Have you ever wondered that? Let's just think about that for a second. Why is the sun not out like it is in the daytime? So, the sun is actually always shining. I'm not sure if you know that. The sun is always shining, but sometimes we can't see it because the earth is spinning around and around. Just like if I were to turn my back to a flashlight or a lamp, right? So here's a little visual for you to see. So if I were to turn my head away from this flashlight, it doesn't look like the flashlight's on to me because I can't see it. But it's because I'm facing the other direction, right? Okay, so remember our lesson about how the earth revolves around the sun? We talked about what revolve means, what does revolve mean? Just think in your head. It means to spin in a circle, right? Yes, we learned that in the last workshop. So I've made a little prop here that looks like our Earth. And we're going to pretend that this ball right here is our planet Earth. And this spot right on Earth, this little red pin here, is where we are standing on Earth right now. It's going to represent where we are right now, okay? So, like I said, the Earth is always spinning, but it takes one full day for the Earth to turn in a full circle because it is so big. The Earth is a really big planet. So I'm going to use my flashlight again to represent our sun. It kind of looks like the sun because it's all bright and shiny. So we're going to use this flashlight to represent the sun, and we know that the Earth revolves around the sun in a circular motion, right? Okay, so I want you to imagine something now. Have you ever heard of the teacup ride from Disneyland? You know the one ride where you get inside a teacup and it spins you around and around in circles? Yeah, okay, so when you're in that teacup, you're spinning around in a circle just like the Earth, right? You're spinning like this in your little teacup. So, did you know that the Earth, just like the teacup ride, spins around in a circle at the same time it's revolving around the sun? So we have two different kinds of movement, right? I'll do that one more time so you can see. So we're spinning around, but we're also revolving. Pretty cool, right? And that's what that looks like. So let's take a second to see what our Earth looks like when it's facing our sun. So here we are again on our little dot. That's where we are on planet Earth. And here's our flashlight representing the sun. So when my sun is facing this pin, what do we know? And I'll give you a second to think about that, okay? So we know that when our sun is facing us, it's daytime because we can see it's all bright on that side of the Earth, right? But we know too that the Earth is spinning. So if the Earth is spinning, that means sometimes our spot on Earth isn't going to be all lit up anymore, but the other side of the Earth is. So what does it mean when we over here are all dark and the sun isn't shining? So I'll give you a second to think about that too. Okay, think about it in your head. What does it mean if the sun is not shining on our side of the earth? If you answered daytime, or nighttime, I'm sorry, if you answered nighttime, you're right. Great job. So the next time you go to bed at night, I want you to think about this little demonstration we did, where it's bright out, and then the earth slowly turns, and then it's nighttime. And one other thing I want you to think about is that just because we might have light in our day at one point, that doesn't mean that these people on the other side of the earth also have light in their day. So it might mean that these people on the other side of the earth are asleep, right? Because we go to bed when it's nighttime and it's all dark outside. Okay, pretty cool, right? So with this being said, I want to ask you another question about nighttime and the solar system. So think about this in your head again. What do you see other than the stars when you look up into the night sky and it's all dark outside? Other than the stars, what might you see? Has anyone ever seen the moon up in the sky at nighttime? Yeah, I have too. So remember our conversation that we had about how the earth revolves around the sun. Did you know that the only thing that revolves around our earth is the moon? So that means that our moon goes around our earth, just like the earth goes around the sun, right? So we know that this means that the moon moves in a circular motion, right? Because that's what revolves means. And just like the earth, the moon is never standing still. Have you ever noticed that when you look up into the night sky at the moon, sometimes our moon doesn't look the same all the time? Sometimes you might look at the moon and it might look like this, that bright circle in the sky. I'm sure you guys have seen the moon look like that, but other times that same moon looks like this. It looks like a little C. So how does that happen? If that's our same moon, then why does it look different sometimes? So this is because one of two things. So one reason why the moon changes its shape is because the moon reflects light from the sun. So the moon is kind of like a mirror if you think about it. So we know that when we look in the mirror, maybe you're brushing your teeth in the morning before school, or you're getting your hair done. We know that when we look into a mirror, we see our reflection. We see what we are looking at right back at us. So if the moon is like a mirror and the sun is shining at it, that means the sunshine is going to bounce off of the moon. And we're going to see the sun again from a different angle, right? So, and another reason why the moon looks different sometimes than others is because what we talked about, the moon revolves around the earth. So, the position of the earth and the moon create what we call phases. And I've created a little simple craft for you guys to explain what phases means and what that looks like with the moon. So this is what I've made for you. This is my little moon craft, and I've made it out of Oreos. So I'm sure some of you have Oreos at home. And luckily, when I made this craft, I didn't eat all the Oreos, even though I kind of wanted to, because I love Oreos. Okay, so when the moon looks like this, that is called a new moon. And a new moon looks very dark from where we are on Earth because it's blocking the sun. So we don't get any sunshine with a new moon. When the moon looks like this, that is called a first quarter moon. And a first quarter moon is half lit up by the sun. So it kind of looks like a D, doesn't it? Yeah, and you guys learned about the letter D in the alphabet, so you know what a D looks like, right? And then when the moon looks like this, it's called a full moon. And a full moon is when the whole sun lights up the whole moon. So it's that bright circle in the sky, just like this picture I showed you earlier. Remember that? That's our full moon. Okay. And lastly, when our moon looks like this, that is what we call a last quarter moon. And a last quarter moon is when the sun slowly becomes, the light on the moon becomes smaller and smaller from the sun. So it starts to kind of look like a letter C. And you guys know what a letter C looks like too, from your alphabet, right? Yeah, it's pretty cool. So next time, maybe you go outside with your family or friends at night and you're looking up high into the sky and it's all dark out, look at the moon. Try to find the moon somewhere up there and try to figure out which phase it's in based on the shapes that we've talked about, okay? All right, great job, everybody. So now I'm going to turn it back over to Miss Jen, and she's going to do a little spacesuit brainstorm activity with you. So give her your best attention.
Thank you, Taylor. Oh, that was so interesting to learn about the phases of the moon. And I think I'm going to have to buy some Oreos for myself later today and maybe do that with my kiddos as well. So I know you guys just were able to see the downlink, and we saw some of the astronauts, but they weren't wearing their spacesuits because they were inside the ISS, or the International Space Station. When they go outside, when they're up in outer space, they have to wear a spacesuit. And what's interesting about this spacesuit is that it kind of has a set of superpowers that help support them when they're up in outer space. This spacesuit has a really long name. I'm going to give you that name. It's called an extravehicular mobility unit. I know that sounds very weird, but if you break down each of those words, it starts to make sense. So the first word is extra, and extra just means outside. So this is something that they can wear when they're outside of the space vehicle, or the ISS, the International Space Station. So you might think about vehicles like cars or trucks or tractors, but the ISS also is considered a vehicle, and the astronauts can wear their extravehicular mobility suits when they're outside of that. Now, the mobility piece means that it allows them to move outside of their spaceship. Just like you guys were moving with me a few minutes ago, doing yoga and everything, they can wear their spacesuits so that they can move and collect data and observations that they might get from some of the experiments that they're doing up there. So some of the features that these spacesuits help them, and I said they kind of have superpowers. So the first one is that it helps them breathe. On their back, they have oxygen that they can breathe that lasts for about 6 to 8 hours, so that they can be out there doing their job and they can still have fresh oxygen to breathe. I know breathing doesn't seem like a superpower because we do it all the time without thinking about it, but breathing actually can be a superpower. It's one of the best ways to calm yourself down if you're feeling anxious or nervous or stressed. If you just take a couple minutes and maybe breathe in and out through your nose slowly, it functions like a superpower and helps you regain all your composure and feel calm again. The second thing that the spacesuit provides is air pressure. So there's no air pressure up in outer space, and it's kind of hard for us to picture what that's like because we don't really notice air pressure unless we're out in the wind or if there's a fan that's blowing on us. So you can try to do that. All of a sudden, we become aware of the air that might come towards our face, but until we actually did that activity, it just sort of is there, just like breathing is. So air pressure is provided in this suit so that it helps them feel like they feel when they're on Earth. The next thing that a spacesuit does is it helps them regulate their temperature. So a few minutes ago, we heard about that temperature variation, like how cold and how hot it can get up in outer space. So the spacesuit has all of these tiny little tubes, about 300 feet of tubing that helps warm their body if they're feeling cold and cool down their body if they're feeling too hot. So it's almost like taking a nice cold drink of water or jumping into a pool on a really hot day. And then finally, the last superpower is that it protects them from stuff that's outside. So one of the students I heard asked a question about space dust. What happens if it hits the space station? And so while they're outside of the spaceship working, there's a chance for rocks or dust to come towards them because they're out in space. So the spacesuit provides some padding, some protection from that dust or the meteors that are out there. So basically a spacesuit is a real suit that has superpowers that helps the astronauts survive when they're in outer space. What kinds of superpowers would you want to add to a spacesuit if you had the chance to do that? So right now we have scientists that are working on how to make improvements to the spacesuit that exists. And this is where scientists get to use their imagination and their curiosity to try to come up with new solutions to existing problems. So I want you to think for a few minutes, if you could add any superpower to a spacesuit, what might it be? You think about that, and I'm going to give you an example of something that I thought of. So one thing that I thought of is having a spacesuit with different snacks. So I put some pizza and some tacos on the spacesuit that I made. But the other thing I thought about is astronauts probably miss their pets when they're up in space. So wouldn't it be cool if we could bring our pets up and put them in our spacesuits as well, and they could still be with us while we were up in space? So those are some of the ways that I used my imagination to think about what other superpowers could be on the spacesuit. I know, Miss Sophia, I was going to ask you if you thought of any superpowers that you would add to your spacesuit.
If I could add something to my spacesuit, I'd maybe add those screens, like read my favorite book while I'm doing my astronaut things.
Oh, awesome. So you could always have a book with you, kind of like your own library when you're out in outer space. Taylor, what about you?
I think if I were to add anything to my spacesuit, I would add night vision goggles in my astronaut helmet because it's very dark in space, so I could see everything around me.
That is a very good solution. And one thing I forgot to tell you, this might be an extra superpower, is when they have their helmet on, they can't really move their head around at all, but they also can't scratch an itch if they get one. So if they get an itch on their nose, they're kind of stuck. So maybe we could build into their helmets some sort of feature that could come out and scratch their face if they needed it. The cool thing about this, though, is that you get to use your creativity to try to think about this, and that's what scientists do. So I'm a scientist myself, and it's one of the favorite things my favorite things about my job is that you get to be creative and come up with new ideas. Next, we're going to work on a space song. I know I sang for you before. Luckily, you don't have to hear me sing again. This time it's going to be Miss Sophia. And since we talked about the moon and the different phases of the moon, we thought we would finish today with a song about the phases of the moon. So I hope that you are as excited as I am to sing with Miss Sophia.
Hi, so I am Miss Sophia, and what I'm going to do is I'm going to say a line one by one, and I want you to repeat after me. So here we go. The moon is a sphere, big and white.
The moon is a sphere, big and white.
Big and white.
It loves to reflect the sun's bright light.
It
loves to reflect the sun's bright light.
It goes on a journey every 28th day.
It goes on a journey every 28th day.
Around the earth, a game it will play.
Around the earth, a game it will play.
In the beginning, it is new.
In the beginning, it is new.
Out of sight for me and you.
Out of sight for me and you.
Then it waxes in white.
Then it waxes in white.
As it grows on its right.
As it grows on its right.
Waxing crescent and quarter.
Waxing crescent and quarter.
Then gibbous two.
Then gibbous two.
When full, the phases are halfway through.
When full, the phases are halfway through.
Now it flips to the left and starts to wane.
Now it flips to the left and starts to wane.
As it fades away in its orbit lane.
As it fades away in its orbit lane.
Waning, gibbous and quarter, then crescent two.
Waning, gibbous and quarter, then crescent two.
It's completed its orbit and back to new.
It's completed its orbit and back to new.
Good job, everybody.
Thank you.
And now we are going back to Miss Taylor for closing remarks.
All right, great job, everybody. And thank you all so much again for coming to this amazing conference today. And thank you to your teachers for allowing you to participate in this today. It's been filled with so many amazing workshops, and we hope that you loved learning about science and listening to our astronauts in space, which was a pretty cool experience. Today definitely would not have been as special if you had not come. So we appreciate you being here and being such great listeners and learners, and continue to be great students in school, because maybe someday if you're a good student, you can be an astronaut too. Yeah. All right. Well, everybody, you have a great day and have a great weekend, and be good for your teachers. All right. Thank you, everybody.
Bye.
Thank
Bye.
you.